Okay, so let's solve this question, which states that two rectangular sheet of paper M and N of dimensions 6 cross 1 each, right? So basically they have given us that two rectangles are present and both of their dimensions are 6 cross 1, right? So let's draw them so that we have a very better visualization with us, right? So this is a rectangle that we have, right? One side is 6, one side is 1, right? We have two of these, right? So let's have two of these, and one of them is M, one of them is basically your M, the second one is your N. Okay, very good. Now let's see what they are telling us. They are telling us that sheet M is rolled to form an open cylinder by bringing the shorter edges of the sheet together, right? So this is the shorter edge, and the sheet of paper, rectangular sheet of paper, is basically bent to form a cylinder, right? Okay, that is what we are required. But obviously when we are reading now, sometimes silly mistake happens by is a silly mistake that is done by student is that they are going to say that shorter edges are being rolled, right? So they will imagine that this is being rolled like this, and the resultant of the resultant cylinder is going to be of this sort, right? So that would be a wrong interpretation, and the result that the students is going to get from that kind of analysis is going to be completely wrong. That basically demoralizes the student in the examination, and not only this question is hampered, but other questions are also hampered. So when this kind of very high specific information is presented in the question, now just spend a second into that and read it very clearly and slowly, so that mistakes are not made in that sense, right? So this is a wrong interpretation, and we should not be doing this kind of silly mistake, right? So that is not the case. So we are bending along, rolling along this line, right? So what we are going to get, we are going to get a shape that would look like this thing, right? Would look like this thing. This is the cylinder that we're going to get, right? Obviously, as I have more time with this question than you do, I will basically show how it is rolled, so that you have exact understanding what exactly is happening from this to this, right? So let's look at that also. Not very difficult. So this is how it is rolled, right? So at the original part, this portion, at the original part, right, this portion, this length was of 6, right? So when we fold it, right, when we fold it, and the result come out to be, right, so this kind of circumference you get, right? So this length, that original length, basically folded into this circle that is being present, right? So this length is basically equal to circumference of this lower circle or the upper circle also, right? So that is something that we know, right? And that part we know. Let's just mark it like that this we know this part, and this thing is basically equal to the circumference that is present over here, right? Circumference that is present over here also, right? So now what? So they are saying that it is rolled along this thing. Okay, sheet N is cut into equal square patches. Okay, this is basically cut into equal square patches and assembled to form a largest possible closed cube. Okay, so basically they did not tell the size of the square patches that this sheet is going to be broken into, right? So we can take infinitesimally small patches, right? So basically the whole of this area, every single element of its area can be used by making the squares very small, right? Once that part is very clear to you, now let's see. We have to make a closed cube, right? Because this is a 2D object, and from this a 3D object is being constructed. That 3D object's only surface is going to be filled, inside it is going to be empty, right? So if this is the cube that we have, right, and a cube is completely described by having one of its edges length, right? So let's assume this edge's length being A, then the total surface area of this cube is going to be equal to the basically area of this sheet of rectangular sheet of paper, right? And that is basically what is happening, because every single infinitesimal piece of square is going to come on top over here, like this. It is going to happen, right? Very simple, very easy. Now what is the total surface area? What is the formula that gives total surface area of a cube? That is basically equals to 6a square. Okay, and what is the total area of this thing? Total area of this thing is equals to 6 cross 1, that is 6. Very good. Now we have the whole thing. Now we have to equate this thing and this thing. Okay, let's do that. We're going to get our A. right? So 6a square is basically equals to your 6. 6 gets cut. A square is equals to 1. A becomes 1, right? This part we can then remove because it does not matter. A we have found. Now what is the volume of this thing? The volume of this thing is given by volume is basically equal to a cube, that is going to be equal to 1, right? So we have the volume of the cube. Now let's read forward, right? I went ahead a bit ahead right over here. So n is cut into equal square patches and assembled to form a largest possible closed cube. That part we have done. Assume the ends of the cylinder are closed. Okay, basically these portions are closed. That is what they are telling. The ends of the cylinder are basically these portions. The ratio of the volume of the cylinder to that of the cube is, right? So if the answer is represented by A and S, so the answer that they are looking for is basically equals to volume of your cylinder by volume of your cube, right? Volume of cube we know is basically equals to a cube, that is basically equals to 1, right? So we can directly cut this denominator because anything divided by 1 is basically that thing only, right? So this is, we just need to find the volume of the cylinder, right? So how are going to, what is the formula for volume of the cylinder? It is basically equals to pi r square h. Okay, very good. Now what? So do we know that this h is not written very well? H, right? H is what? This thing over here is your h. This thing over here is your h, while r is basically the radius of this circle that is present at the bottom, or the circle that is present on the top as well, right? So if we represent that by r, so how can we find r? We know that the circumference is basically equals to 6, and we also know that the formula for circumference is 2 pi r, right? So we can find r by using the formula, equating the formula driven circumference by the given circumference, right? So that is going to be equal to 2 pi r is equals to 6. Let's use this formula to find the r, and we know the h is basically equals to 1 because this portion came from here, right? This portion came from here. So from that, let's do that. So we have 2 pi r, this is answer, right? 2 pi r is equals to your 6. We cut it like this, we get this. R is equals to 3 by pi. Okay, now let's apply this this result into this, and we're going to have our answer. That is going to equal to pi 3 by pi whole square h. H is basically equals to 1. We can cut that. Okay, so what is that going to give us? Pi times 9 by pi square. We can cut this and get the answer as 9 by pi, right? Is there any option that matches this kind of result? Yes, option C matches this result, and that is going to be our answer. Extremely simple question. I hope that this video served as a validation to the solution that you already have done by yourself, because solving question by yourself is very important, man. Don't just use because the sense of understanding the question that you get from somebody else solving it as you have already understood it. No, solve it by yourself. Practice that you done deliberately on your own improvement is the only key to basically compete in GATE. So you must solve it by yourself and use any solution videos, not just this one, as only validation, right? Other than that, have a very good day. Thanks for watching the video.